This next part, we're going to be taking this big pile of log and putting it into a sum and difference of logarithms and then expressing powers as factors. So we're basically going to be expanding this logarithm. And then here in a couple pages, we're going to be reversing that process and writing each expression as a single log. So we're learning how to go back and forth between this condensed version and this expanded version. This is where the analogy comes in. So I look at this like it is a log apartment building. And the type of building it is base 10. It's a common log. And so I want to know how many apartments there are in this log condo or how many people are living in it. And so the way that I determine that is by looking at how many factors there are. So a factor, remember, is something that is separated by multiplication. So if I look at this, I have 6 times x to the 5th times y cubed in the numerator, and then 5 times the square root of z in the denominator. So I would consider that to have 3 factors or 3 roommates in the numerator or in the upstairs, and 2 factors or 2 roommates in the denominator. So the thing about these 5 roommates is that they want to move out into their own living spaces, but they do like the style of home. They just want to live in their own separate homes. So what I'm going to do is I'm going to move all 5 of these people into their own log homes. So I'm going to end up needing 5 separate logarithms, and they will all be of that same type. So log, 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 log. So that's kind of my first step, is that each factor will become its own logarithm. So each factor or roomie that is separated by multiplication will become its own factor, its own logarithm. And remember to keep the same style. So if this had been like base 5, then all of these would be base 5. But it was a common log, so they're all going to be common logs. The next thing that we want to think about is where those roomies were living, because upstairs roomies and downstairs roomies have different demeanors, like different attitudes. Upstairs roomies or upstairs factors are positive. Downstairs roomies, downstairs factors are like basement, negative, like emo. Not that there's anything wrong with the emos or they're all negative, but it's an analogy. So you just kind of have to go along with it. So the upstairs factors or numerator factors are going to become positive logs. The downstairs factors or denominator factors, the roomies that were living downstairs, are going to become negative logs. So my 6 was a positive log, so it is positive. I could put a plus sign out in front. That one's not necessary. My x to the 5th is positive. My y to the 3rd is positive. Then I'm moving downstairs, so log of 5 is negative, and log of square root of z is negative. So now all 5 of my roommates are moved out into their own log homes. Well, after we move out into our own places, then we want to spread out and decorate. Like this x to the 5th has been storing some of its Christmas decorations up in the attic, and now it would like to put that Christmas decoration out on display in its lawn. So it's going to take this power that it's been packed up in its exponent and put it out in front for the entire world to see. So the next thing we're going to do is unpack the powers. So we will unpack this 5 that's on the x. We will unpack the 3 that is on the y. And there's one power that's kind of disguised right now. Remember those radicals? Those radicals were a power of 1/2. So we're going to unpack that power as well. So by the time we get all of those unpacked and written out front, the answer to expanding this logarithm will be a common log of 6 plus 5 times common log of x plus 3 times common log of y minus the common log of 5 minus 1/2 times the common log of z. And that's what an answer to these kinds of problems looks like. We have written our log as a sum and difference of logs, and we expressed powers as factors. So our power was a 5. When we bring it out front, now it becomes a factor because it is multiplied. Okay, let's look here. Log base 6 of y divided by y plus 3. So again, we need to decide what style is the home and how many of these homes are we going to need to build. So I look at my roomies, upstairs and downstairs. So upstairs I have one roomie. It is a y. So I know I'm going to need at least a log base 6 for my upstairs guy. Then downstairs, remember that my factors are separated by multiplication. Well, these two are added. So that's actually only one roomie. So I'm going to need only 2 log homes because these are not multiplied. They are added. Okay, now let's talk about, positive and negative. Upstairs factors are positive. So my log base 6 of y is positive. And then the y plus 3 is negative. So here I go with my y plus 3. Now, this is not quite accurate. When I move this y plus 3 into its own home, out of the basement of that stacked log, I have to put it in parentheses. It's like I had a single roomie upstairs, but this was like a married couple living in the basement. So I have to enclose them like this is the wedding ring for the Y, this is the wedding ring for the 3. Now everyone knows they were married and they stay together forever. So, in my story they do. So I have to put this Y plus 3 in parentheses or that's not going to be a correct answer. So there's no powers to unpack. So this actually ends up being the entire answer for that problem. There's nothing else I can do. Let's get some more practice with these though. Next example. How many roomies do we have? Let's see. Upstairs, I have 1 roomie from x to the 5th. Downstairs, here's another one of these married couples, 1 minus x. So that's actually only 1 roomie as well. So I only need 2 of these natural logs. So I'm going to need a natural log and another natural log. 2 natural logs. Let's talk upstairs, downstairs. So upstairs I had an x to the 5th, which would be a positive. Downstairs I had a 1 minus x in a cube root. Well, I'm going to go ahead and take this opportunity to make it 1 minus x to the 1/3 and make it negative. Remember to keep those parentheses so that everyone knows the 1 minus x was that married couple living in the basement. And the 1/3 power goes to both of them because both were living inside that cube root. Now, the reason I went ahead and wrote my cube root as a 1/3 power is because my next step is going to be to unpack the powers. So I'm going to unpack this 5. I'm going to unpack this 1/3. And then when I do that and rewrite my final answer, that's going to end up being 5 times the natural log of x minus 1/3 times the natural log of, remember to keep that couple in their parentheses like that, so minus 1/3 times the natural log of 1 minus x. Log base 5 of 25x. Okay, how many roomies? I have 25 times x, so 2 roomies. The style of home is log base 5, so I need 2 of these log base 5 homes. And then they're actually both upstairs because I could write it divided by 1 like that. So log base 5 of 25 and log base 5 of x are both upstairs. Now, I would say that I would be done with this problem, but I see that I can answer this question because log base 5 of 25 is asking me 5 raised to what power gives me 25. So the value of log base 5 of 25 is 2. So I need to replace that with a 2, and then I'll have 2 plus log base 5 of x for my ending answer. This one is kind of similar. Now, I would say that these parentheses around the e times x are not necessary since they are multiplied. It would be assumed that they are both inside the argument, just like they were for log base 5 of 25x. But just for funsies, we put them in parentheses. That still means I have 2 factors or 2 roomies, and the style will be a natural log. So I'm going to need 2 of those. Both of my roomies are upstairs, so natural log of e and natural log of x both are added. And then I can evaluate this, the natural log of e. Natural log of e is asking me e to what power gives me e. That's one of my properties. E to the first power is e, so the natural log of e is 1. So then I'll have 1 plus natural log of x. All right, natural log of x over e to the x. So again, we have 2 roomies, one of them in the numerator and one in the denominator. So I need 2 log natural log homes. My upstairs roomie is positive, so natural log of x is positive. My downstairs roomie, e to the x, is negative. Remember, the next thing to do after we move out is to unpack. So I'm unpacking this x here, which is going to give me the natural log of x plus x times the natural log of e. We just saw up here that the natural log of e is 1. So this is natural log of x plus x times 1, which is just going to be the natural log of x plus x. Oh, I changed that to a minus. I bet you guys were super confused. That is my bad entirely. Minus. Minus, minus, minus. Okay, this guy. This little piece over here is telling us not to worry about this 1 minus x being inside of an even index radical. They've gone ahead and taken care of the domain concern for you in that case. So we can just go ahead with our properties and deciding how many natural log homes we're going to need. So in my argument, I have x squared times square root of 1 minus x. So there's only one place where we have multiplication, so that gives me 2 roomies. So I'm going to need 2 natural logs. Both of them are upstairs, so both are positive. I have x squared in one of them, and I have square root of 1 minus x, which is the same thing as 1 minus x to the 1/2. So then I can go ahead and bring down my powers, unpack. And I'm going to end up with 2 times natural log of x plus 1/2 times natural log of 1 minus x. Make sure those stay in the parentheses. Last one on this page. So the style of our home is a common log. How many roomies do we have? We have 1, 2 in the numerator and 1 in the denominator. Again, this is here for domain because remember that logarithms have to have positive arguments. So although not all of the examples and not all of the MyMathLab problems are going to tell you anything about your domain, if they do, it's going to look something like that, and it's not anything to worry about. It's just a little extra information. So back to our problem, we're going to move these into 3 common log homes. So I need a common log, common log, a common log. Then I had 2 roomies that were upstairs. I had an x and an x plus 2. Now remember that the x plus 2 is that couple, so they need to stay together in parentheses. And then the denominator, so minus, and that was x plus 3 squared. After they get all moved out, they're going to unpack. So this squared is going to go out to the front lawn, and we'll end up with common log of x plus common log of x plus 2 minus 2 times the common log of x plus 3. Whoops. In our next section, we're going to be, oh no, we get to some more examples, yes. And then after that, we're going to be doing the reverse. So a couple more examples of this style. So we're going to unpack or move all of these roomies into their own log homes, log cabins. So here we've got the natural log of this whole thing to the 1/3 power. And then we have x squared minus x minus 2 in the numerator and x plus 4 squared in the denominator. So I do want to look at a couple of different ways that we can approach this problem. First of all, in both methods, I would want to consider factoring the x squared minus x minus 2. So I would kind of just replace this with x minus 2 times x plus 1. Now that doesn't help us from a standpoint of being able to simplify anything, but it is going to help us from a standpoint of being able to move all of the factors out into their own natural logarithms. Again, here's the thing about domain. Don't worry about it. It's just letting us know what that domain would be restricted to. So the 2 ways that we could handle this, the first way that we could handle it is we could take this 1/3 and we could unpack it to the front right away. So we can unpack it out here and make it 1/3 times, and then the whole problem that we had. I probably don't want to use that color. I will use that. My apologies. 1/3 times the natural log of, then we still have this x minus 2 times x plus 1 divided by x plus 4 squared. Now, in the alternative method, we're going to do something different with that 1/3. So we'll come back to the other method in a moment. Just so you're aware, we're going to do this problem twice. It's so nice we work it twice. Okay. So first method, I'm pulling that 1/3 out to the front. Then I am going to break these factors into their own log homes. So I see that I have 2 upstairs roomies and 1 downstairs roomie. So I'm going to make this into 3 log homes. One of them is positive, the x minus 2. The next one is positive, the x plus 1. And the third one is negative, the x plus 4 squared, because it was in the basement. Now here's the thing about this 1/3. This 1/3 was a shared decoration. So like it was actually out in front of the entire building. So they each get to take that 1/3 with them because that 1/3 belonged to everyone in the apartment complex. So that's going to be distributed to each of these new log homes. Additionally, I am going to be bringing this 2 down in front of that home. But this one was the only one that had the exponent of 2. So when I go to take that 1/3 along, I'm going to have 1/3 times the natural log of x minus 2 from this factor plus 1/3 times the natural log of x plus 1 from this factor, and then minus 1/3 times the 2 that I'm bringing out in front, so minus 2/3 times the natural log of x plus 4. Now in my alternate method, instead of bringing that 1/3 down in front and distributing it, I am going to take this 1/3 and apply it to each factor. So I am going to make this x minus 2. I'm going to raise that to the 1/3. I'm going to make x plus 1 up to the 1/3 and x plus 4 squared to the 1/3. Now remember, in that denominator, when you raise a power up to a power, you multiply their exponents. So this then gets rewritten as the natural log of x minus 2 to the 1/3 times x plus 1 to the 1/3. And in the denominator, I'll have x plus 4 to the 2/3. Now, a big parenthesis is optional. If you prefer it, go ahead and put a big parenthesis around the whole thing. We didn't need it here once we took the 1/3 off, but I kept it. So you keep it or don't keep it, the big parenthesis. But then we're going to be moving out into our individual log homes, which I can see that I have 1, 2, 3 roommates. So I need 1, 2, 3. I have an upstairs roomie, so positive, that is x minus 2 to the 1/3. I have another roomie that is positive, x plus 1 to the 1/3. And then that downstairs is minus x plus 4 to the 2/3. The lighting is changing in here with the sun going down. I hope you can still see. Sorry. And then I'm going to unpack my exponents to the front. So bring out the 1/3, bring out the 1/3, bring out the 2/3. And what you should see is at the end, we have the same answer we had by the first method, 1/3 times the natural log of x minus 2 plus 1/3 times, natural log of x plus 1 minus 2/3 times the natural log of x plus 4. So either method works. It's just whichever one makes the most sense to your brain about what process to do first. Let's see this guy. Here we have the natural log of 5x times square root of 1 plus 3x over x minus 4 cubed. So how many roomies do we have? How many do we have up? How many do we have down? So downstairs roomies, we have 1. It's x minus 4 cubed. Upstairs roomies, we actually have 3. We have 5 times x times square root of 1 plus 3x. So altogether, we have 4. So I'm going to need 4 natural logs to move these guys out into. My upstairs roomies that end up being positive logs are 5, that's positive, x, that's positive, and square root of 1 plus 3x. And then my negative roomie from the downstairs was x minus 4 cubed. After they all get moved out, remember they're going to unpack. So I have this 3 to unpack in front of this logarithm. And then my other one, this guy, remember that is an exponent of 1/2. That gets unpacked in the front as well. So we're going to end up with the natural log of 5 plus the natural log of x plus 1/2 times the natural log of 1 plus 3x. Remember to get that 1 plus 3x in parentheses. And then minus 3 natural logs of x minus 4, which also needs to stay in parentheses. Now my next section is going to go in reverse, and we're going to come back and do that another time.